This is Algebra 2, Unit 9, Lesson 4 on the discriminant of a quadratic. Now, since the roots of a quadratic can be found using the quadratic formula, if a, b, and c are rational numbers, the quantity under the square root, the b squared minus 4ac part, this part right here, will determine what kind of roots that you have. Because what we are going to look at is what kind of number we get when you do the b squared minus 4ac. It indicates what type of number the roots of the quadratic and its x-intercepts turn out to be. So there are 4 cases that we're going to look at. So we are going to, for each of the following quadratics, calculate its discriminant, its roots, and state the number and nature, whether they're rational, irrational, or imaginary of the roots. Okay, so let's look at the discriminant as a perfect square. All right, so if I'm going to look at the discriminant, b squared minus 4ac, in this problem, a is going to be 1, b is 3, c is negative 10, based on this equation right here. Okay, so b squared would be 3 squared minus 4 times 1 times negative 10. All right, go to my calculator. I probably do this in my head, but just to show you that you do it in the calculator too. Minus 4, oops, 3 squared minus 4 times 1 times negative 10 is 49. So 49 is what this works out to be. That is a perfect square. So if I took the quadratic formula right now and I plugged in 49 into the square root, I would get x equals negative b would be negative 3 plus or minus the square root of 49. That's this right here, all over 2 times 1. Okay, so this is actually going to be negative 3 plus or minus 7 over 2. This is a perfect square. Okay, so there's actually 2 answers here. Negative 3 plus 7 over 2, which is negative 3 plus 7 is 4 over 2, which is 2. And x equals negative 3 minus 7 over 2, which is negative 10 over 2, which is negative 5. Okay, so I got, when that's a perfect square, what kind of roots did I get here? I got 2 unequal, they're not the same, rational roots. So if your discriminant comes out to be a perfect square, if this part right here is going to be a perfect square under the radical, that means your 2 answers are going to be rational numbers that are unequal. All right, now what happens if the discriminant is not a perfect square? Let's try it out. B squared minus 4ac. B squared would be, in this case, negative 6 squared minus 4 times a is 1 times c is 7. A, B, C. So that gives me 36 minus 28, which is 8. So if I do my quadratic formula, x equals negative b would be 6 plus or minus the square root of 8 all over 2 times 1 is 2. So we know 8 is going to be 4 times 2, so that's going to be 2 radical 2. X is equal to 6 plus or minus 2 radical 2 over 2, which divides out to be 6 over 2 plus or minus 2 radical 2 over 2. So that's 3 plus or minus radical 2. Okay, so I have 2 roots there, 3 plus radical 2 and 3 minus radical 2. What kind of roots are those? They are irrational. So this gives me 2 unequal irrational roots because we have the square root of 2 in there. So when your discriminant is a rational number, or that's not a perfect square, then that means you're going to have 2 unequal irrational roots. When it was a perfect square, you're going to have 2 rational roots. Okay, now what happens if the discriminant is equal to 0? That's our third choice. All right, so b squared minus 4ac, b in this case is going to be negative 10 squared minus 4 times a is 1 times c is 25. So this is going to be 100 minus 100, which is 0. So if I use the quadratic formula, negative b would be 10 plus or minus the square root of 0 all over 2 times 1 is 2. So that's 10 plus or minus 0 is just going to be 10 over 2, which is equal to 5. So what does that tell me? How many roots did I get? I only got one root. So technically, what this is going to be, there's actually two unequal roots, or two equal roots here. So this is called one double root, double rational root. Or sometimes called two equal rational roots. Now the 2 comes from, this is actually 10 plus the square root of 0 over 2 and 10 minus the square root of 0 over 2, which is actually, the square root of 0 is just going to be 0 for each one of these. So that's where the double part of it comes from. So x is going to equal 5 for either one of them. So if your discriminant is 0, that means you're going to have only one root. That's technically you have two roots that are the same thing. So, and the roots will be rational because it comes out to be a whole number or a fraction. It comes out to be a rational number. All right, our last case is when the discriminant is less than 0 or negative. If your discriminant is negative, what kind of roots will you have? All right, well, let's see what we have. B squared minus 4ac. B is negative 8 squared minus 4 times a is 1 times c is 20. So that's 64 minus 80, which is negative 16. Okay, so if I use the quadratic formula and plug in my discriminant I just found, negative b would be 8 plus or minus the square root of negative 16 all over 2 times 1. All right, so this is, what is the square root of negative 16? Well, since this is a negative, remember it's 16 times negative 1. What's the square root of 16 is 4. Square root of negative 1 is I. So this is going to be 8 plus or minus 4i over 2. And when I simplify that, I get 8 over 2 plus or minus 4i over 2. So you get 4 plus or minus 2i. So how many roots do I have? I have two roots. They are unequal because one is 4 plus 2i and the other one is going to be 4 minus 2i. And what kind of roots are they? Are they rational? No. These are actually going to be imaginary roots because it has an I in it. These are complex numbers. So it's going to be two unequal imaginary roots. So what your discriminant is determines what kind of roots you're going to have. So we have 4 different cases. If it comes out to be a perfect square, then the roots are going to be unequal and rational. If it is not a perfect square, they're going to be unequal and irrational. If it comes out to be 0, it's going to be one root or technically one double root. And if it's negative, if your discriminant is negative, that means you're going to have imaginary roots. All right, so by only using the discriminant, determine the number and nature of the roots of each of the following quadratics. So using b squared minus 4ac, let's determine what kind of roots we have. All right, b squared minus 4ac. b in this case would be 7 squared minus 4 times 2 is a times 1, c is negative 4. So this is going to be 49 plus 32, which is 81. This is a perfect square. So what does that tell me? You're going to have two rational, unequal roots. So that means you're going to have two unequal rational roots. Okay, because this is a perfect square, under the discriminant that would come out to be 9, and then when you use the quadratic formula, you get two rational roots. Okay, b squared minus 4ac. b is negative 8 squared minus 4 times a is 1 times c is 25. So this would be 64 minus 100, which is negative 36. Well, that's a negative number. What kind of roots you're going to have? Well, if that's under the square root, that means you're going to have an imaginary number. So that means you're going to have two unequal imaginary roots. Okay? b squared minus 4ac. b is going to be 4 squared minus 4 times a is 4 times c is 1. So this is 16 minus 16, which is 0. So that tells me under the square root, it's going to be a 0. It's going to have only one root. So you're going to have one double rational root. Or two equal roots. Okay, so, but they're still going to be rational. Okay, all right, so let's have you do the next three and see if we can know what kind of roots we are going to have for each of these. All right, consider the quadratic function whose equation is y equals x squared minus 4x plus 4. Determine the number of x-intercepts of this quadratic from the value of its discriminant, and then sketch the graph. Okay, so we say this parabola is tangent to the x-axis. Let's see what that means. All right, so let's start out with b squared minus 4ac. All right, so b in this case is going to be negative 4 squared minus 4 times a is 1 times c is 4. This is going to be 16 minus 16, which is 0. So if this is 0, that means you're going to have one double rational root. So that tells me how many times is this going to hit the x-axis. Well, it should only hit the x-axis once. It has one x-intercept. So let's see if we can graph this. First of all, let's set the window. The graph is from negative 2 to 6 for the x's, from negative 2 to 6 for the x's, and from negative 2 to 10 for the y's. So from negative 2 to 10 for the y's, go to my y equals, and I want to put an x squared minus 4x plus 4. Squared minus 4x plus 4. If I go to my graph, whoop, that's my table. Here's my graph. Okay, how many times did it hit the x-axis? It only hit the x-axis once. It has an x-intercept right there. So when I sketch this, it looks something like this. It's going to go down like this. It's going to touch the x-axis and come up like this. So this value right here, that is the one root. So when you see your parabola like this is y equals x squared minus 4x plus 4, it is only going to touch it in one place. So it's going to have one x-intercept as one root. Okay, so which of the following parabolas has two unequal rational x-intercepts? All right, what kind of discriminant would we have right here if it's two unequal rational x-intercepts? Well, that tells me that b squared minus 4ac must be a perfect square. So if b squared minus 4ac must be a perfect square, let's see if we can figure out which one that is. All right, well, b squared minus 4ac on this one, b squared would be negative 2 squared minus 4 times 1 times negative 1, which gives me 4 plus 4, which is 8. Is that a perfect square? Nope, it's not that one. All right, b squared minus 4ac on this one. b would be 2 squared minus 4 times 1 times negative 15. So this would be 4 plus 60, which is 64. That's a perfect square. So this one must have two equal rational x-intercepts. So that means this one has got to be equal rational x-intercepts. All right, and the last one, for what values of a will the parabola y equals ax squared plus 4x plus 2 not cross the x-axis? All right, if it does not cross the x-axis, what kind of roots would it have? It doesn't cross the x-axis, it would have imaginary roots. So what does the discriminant look like if you have imaginary roots? That means b squared minus 4ac must be less than 0, or be negative. Okay, so let's do b squared minus 4ac. b squared would be 4 squared minus 4 times a times 2 has to be less than 0. So 16 minus 8a has got to be less than 0. Subtract the 16. And then divide by negative 8. But what happens when you divide by negative 8? You're going to flip the inequality. So a would have to be greater than 2. So any value of a that is greater than 2 will make this root imaginary. Okay, so now we know the 4 cases for each of the discriminant. Using the discriminant, you can find what each kind of root is and